I am Sheren Hana Wilar. Now, I will present the results of my thesis research with the title
Book Embedding of Infinite Family to H plus 3 choose to crossing critical graph for H equal 1 with rational average degree R element 3.5 until 4. With Supervisory Commission, Professor Dr. Benny Pinonton MSc as Chairman and Christy Montolalu SI MSc as Commission Member. Introduction. Background. Construction of mathematical models can be made in various ways using different mathematical problems. One mathematical model that is well known and can cover a variety of problems is graph theory. Graph theory is a part of discrete mathematics whose application is used to present many practical problems which are highly related to everyday life, such as modeling the types of relationship and process dynamics in the field of physics, biology, chemistry, and social system. In the drawing of a graph G, the vertices of G are points and the edges are simple curves joining their end vertices. The most common way to represent a graph is diagram. An obvious fact about this diagram, the edges may occasionally meet at the point that are not the nodes of the graph. For planar graph, there is always a representation that avoids such crossing at all. But not all graphs are planar, and for the latter kind, an important characteristic is their crossing number. The crossing number of graph G is the minimum number of crossing points of edges in the drawing of G in the plane. The reason for a sparse graph to have many crossings in any drawing are structural. Structure differences can affect the number of intersections of a graph. These reasons can be understood via so-called K-crossing critical graph. According to Bocal et al., a principal tool used in construction of crossing critical graph are tiles. The tile concept was first introduced by Pinonton and Richter in research about crossing numbers of sequences of graph in case-planar tile. Tiles can be arranged by gluing one tile to another and arranged in a linear or circular fashion. The series of tiles with circular fashion form an infinite family graph. In this way, the intersection number of this family of graph can be determined. A book embedding of a graph is a linear ordering of its vertices and a partition of its edges into non-crossing set are called page. In a book embedding, the vertices of graph are restricted to a line refers to the spine of the book, and the edges are drawn at difference of plane delimited by the spine are called page of the book. In Pinonton and Richter research, they gave example the infinite family of 2h plus reduced to crossing critical simple graph with positive integer h and having rational average degree R element 3.5 until 4. In previous research by Pinonton et al., they formed a graph with set h equals 0 and get 3 crossing critical graph. And when they embed the graph into book, they show that page number of book embedding is 3. And in this research, continuing previous research, also will be formed a graph of infinite family to h plus reduced to crossing critical graph with average degree R between 3.5 and 4 for h equals 1. And the graph will be embedded into book. And then will be seen whether the number of pages in the book embedding is the same as the number of crossing on the graph or not. Statement of problem. How is the shape of infinite family to h plus reduced to crossing critical graph for h equal 1 with rational average degree R element 3.5 until 4? How the structure of book embedding of infinite family crossing critical graph, and how many page number in the book embedding of infinite family graph. Objective of problem: to determine the shape of infinite family graph, to determine the structure of book embedding, and to determine the page number in the book embedding of infinite family graph. Purpose of research: for study and lectures. The results of this study are expected to be reference source in learning mathematics, especially in the field of graph theory. For mathematics development, the results of this study can be used as reference source in developing graph theory. Literature review. Graph theory. Graph theory was born in 1736 through the writing of Leonhard Euler, which contained an effort to solve the problem of Königsberg Bridge, which is very famous in Europe. That is, through each of the 7 bridges exactly once and returning to its starting place. Euler answered the problem by modeling this problem into graph. Length are expressed as points, called vertices, and bridge are expressed as lines, called edges. A linear graph or simple graph consists of a group of objects V, called a set of points, and another set of E, which is a set of sides. Crossing number. The crossing number CRG of graph G is the minimum number of crossing points of edges in drawing of G in the plane. Crossing critical graph. A graph G with crossing number k or more is k crossing critical if every proper subgraph has crossing number less than k and G is homomorphically minimal. Crossing numbers are not monotone with respect to construction, since constructing an edge might decrease, increase, or not change the crossing number. Average degree. The average degree of graph G is another measure of how many edges are in set E, compared to number of vertices in set V. The average degree of an undirected graph are formulated by this equation. Tile. A tile is trituple T equal GLR, where G is connected graph, L is finite sequence of vertices, called the left wall, and R is finite sequence of vertices, called the right wall. All the vertices in L and R are distinct. K, M, Z is example of the tile. Q4 is example of the tile arranged in linear fashion, and dot Q4 is example of tile arranged in circular fashion. The tile crossing number TCRT of tile T is the smallest number of crossing in any tile drawing of T. If TCRT equals 0, a tile T is planar and otherwise the tile is non-planar. The twist T of tile T is the tile obtained by reversing the order of R. A tile T1 is compatible with tile T2 if R1 in tile T1 equal L2 in tile T2. A tile is self-compatible if it is compatible to itself. According to Pinonton and Richter, let H be positive integer and let R be rational in the interval 3.5 until 4. There is an infinite family of 2 algebra structures to crossing critical simple graph with average degree R, where the graph consists of 2 little tiles. Book embedding. The concept of book embeddings were first introduced by Ullman in 1973 and Cannon. Book embedding is a graph with vertices embedded in a straight line, with edges assigned colors such that no edges of the same colors cross and no edges cross the line in which the vertices are embedded. A book embedding is a graph with vertices embedded in a circle and edges drawn across the circle and colored in such a way that no crossing edges are of the same color. A book embedding is a topological embedding of a graph with vertices embedded in a straight line and edges residing on all planes such that no edge on the same plane cross. The book embedding plays an important role in fallacy design, matrix computation, parallel processing, and permutation sorting. The page number of graph G, the node P and G, is the minimum number of pages in which it can be embedded without crossing. Research methodology, time and research place. This research will be held in Mathematics Department of Samratulangi University from November 2019 until March 2020. Research methods. The methods that used in this research is literature study by studying the literature related to crossing number of graph, tile graph, and book embedding. Research stage. The step to be used in completing this research you can see in the slide. Results and discussion. Construction of tile. In this research, the tile concept is used to build an infinite family of graphs. Therefore, the first thing to do is construct tile. There are two tiles, tile S and tile B. If tile S and tile B is compatible, then the catenation of the both is SB, where R1 corresponds with L2. From the figure, can be seen vertices E and F of tile S are identified with respectively the vertices U and V of tile B. The tile S is self-compatible. You can see the vertices of R1 are identified with respectively the vertices L2 of the catenation SS. If the tile S is self-compatible, then the tile B is also self-compatible. For H equal 1, the form tile will be added with copy of a long version of S placed sequentially under the tile. This is figure of tile S1 and B1. To get the crossing, the other R must be twisted. For the twist S1 has the tile crossing number 10, and for the twist B1 has the tile crossing number 12. According to the rules of crossing number, to get the smallest crossing number, the twist can only be through the tile S. Refer the theory of tile that has been introduced by Pinonton and Richter. They define an infinite family of 2H posterages to crossing critical graph for H is positive integer with having rational average degree between 3.5 and 4, with gluing together two small pieces of graph with certain condition in circular fashion to build an infinite family of graph. In this research, it will be set H equal 1 and define S more than equal 1, B more than equal 0, S plus B more than equal 2 for the tile P1SB equal SB, where S and B are tile, thus catenation of S copy of tile S and B copies of tile B in linear fashion. And the graph Q1SBN equal dot P action Pn minus 1, where P action is the twist circular catenation of P and Pn minus 1 is the catenation of n minus 1 copies of P. For the example, we'll define S equal 3 and B equal 3, thus forming a tile P in linear fashion. The tile P are planar, where without crossing. To get crossing, the order of R in tile P must be reversed. If the twist is through the tile S, the tile has 10 crossing critical, while if the twist is through the tile B, the tile has 12 crossing critical. Therefore, according to the rules of the tile crossing number, the tile's smallest number of crossing is used, which is the twist through the tile S. Thus, for S more than equal 1, B more than equal 0, and S plus B more than equal 2, the graph Q1SBN has vertices as follows and the edges as follows. And the average degree of Q1SB is formulated by this equation. Can be seen in the slide. This is a figure of graph Q1332 as the example of infinite family 10 crossing critical graphs with rational average degree R element 3.5 until 4. And the next step, the graph Q1SBN embed to the book. When the graph Q1SBN embed to the book, the graph have 4-page book. And this is as the example book embedding of graph Q1332 where have 4-page book. For conclusion, The infinite family of 2H plus to crossing critical graph for H equal 1 has 10 crossing critical. The structure, the book embedding of infinite family graph, key HSBN for H equal 1, form 4 page book. Therefore, page number of book embedding key 1 SBN is 4. For suggestion, hopefully through this research, the researcher can further develop theories about graph, especially tile concept, and find the structure book embedding of infinite family graph with H more than 1 or with other concept.